I don't know if you noticed this, but people are always saying organic chemistry is not about memorization. It's about understanding the principles and the concepts behind everything. In other words, it's less about the what and more about the why. So I actually don't believe this statement. And here's my problem with it. Even though the typical organic chemistry course does talk about why, and even more so the textbook, we spend a lot of time talking about the what. It's like we're learning the why as a means to the what. We're always talking about electronegativity and resonance, but we're learning those things so that, eventually, we can apply those to reactions. We can predict their products and things like that. Yes, the class does focus on some theory in the beginning, but eventually we move to applying that theory to reactions, dozens of them. So you will have to be comfortable with memorization. So whenever someone says, it's not about the memorization, like, I know where you're coming from, but I quadruple hog, triple dog, double frog dare you to name one reaction where you know what the products are by first not remembering what they are, and then deriving them every single time by using theory. And chances are you can't. Because after we derived everything, the first time you learned that reaction, you probably nodded and went like, yeah, so that principle makes sense. And then you wrote down the reaction and memorized it. And that's not bad. It's just how we learn. It's efficient. Understand the principle, memorize the shortcut. It's like when you learn the quadratic formula. Technically, you can derive it if you know the characteristics of a parabola, but you memorized it, like everyone else. They even call it the midnight formula in Germany, Mitternachtsformel. Because if someone wakes you up in the middle of the night and asks, what's the quadratic formula? You should know what it is because you memorized it. Memorization isn't bad. It's a mental shortcut and it saves you time. And don't get me wrong, in OChem you still do need to understand the chemical theory that backs everything up, but it's just a fact that in a course, most of the questions that you'll be asked, and more so in OChem 2, but also in OChem 1, the way you solve them is by having memorized something about a reaction. And of course, applying that through practice. So what's my practical advice to help with memorization? Well, aside from practice, of course, I recommend that you find a sheet of paper, like right now, and dedicate it as your reaction summary sheet. I think you'll find that very helpful. And maybe you do index cards or something, but just some place other than your notes where you keep details about all the reaction types that you learn. Alright, enough about that. I'm gonna give you a few more tips on how to succeed in organic chemistry. And these are things that I personally did, so I hope they help you as well. The first one is to work on your spatial thinking. In OChem, you're going to be twisting molecules and thinking about what side of a molecule a substituent is going to be on, and maybe twisting and then thinking about which side, all sorts of things. A lot of people think that spatial thinking is just something you're born with, like you're either naturally good at it or bad at it. There's this whole thing about men being better than women at spatial thinking. But here's my take on that. I think that people who are better at spatial thinking, what that actually means is that they're just faster at thinking about shapes. So for someone like me who has, say, a medium level of spatial thinking ability, well, I'd say that you still can arrive at the same conclusions as people who think faster, but you just have to be more comfortable with being patient and just thinking through a problem more slowly. It's not that you can't get there, just be patient, and I find that that helps. And other than being patient, there are some other tips that will help you with 3D spatial thinking. First is to draw. Draw molecules, because if you're just thinking about them, it's more likely that you'll make a mistake by, for instance, mixing up and down or left and right or something like that. If you draw everything down, you can see where the parts of a molecule are, and you can track their changes more easily. 2, you can use your hands, and for instance, you could do the left and right thing to figure out which side is left, because L for left. I still have to do that every time, but you can also use your hands for tracking atoms. For instance, use your 3 fingers like this, and if this is a carbon, if you rotate it a certain number of degrees, you can see where that atom is now. Things like that. You have your hands, so why not use them? And third, you should think about animals. For instance, let's look at a dog. So here we have the body of the dog from the chest to the rear end of the dog, and that's a bond, for instance, between two carbon atoms. And now this carbon atom is bonded to 3 other substituents. And you can think of them as the head of the dog and 2 of the legs. But instead of feet, you have, for instance, another carbon atom or an OH or something. So now if the dog is like twisting itself some way, you can think, I don't have to remember the orientation of the molecule per se, but the dog's left foot was an OH, and if the dog rotated, now the left foot is like, it's here or something. And it just helps you with figuring out where in space a particular substituent is. And of course, back here you have the 2 hind legs and a tail. And you don't have to use dogs, you can use cats, horses. I've actually literally gone to office hours and talked to professors and classmates about reindeer because their antlers stick out, and that's like, you get more substituents from that. So yeah, animals, they actually help you with organic chemistry. So you don't have to be fast. Who cares about fast? You should just be patient, use these tips, and be correct. Slow and steady wins the race. My next tip is on notes. This is really fast. I suggest that you read the textbook on the material that you'll be covering in class, before class, but don't take notes, just read to understand. Or if you're taking notes, just take a little bit. Then in class, that's when you want to actually take notes, because your teacher will point out what is important. Moving on to homework. My biggest tip is to think of the problems as puzzles, because then they become fun. Also, make sure to join the class group chat. When I took OChem, we organized study groups in the group chat, and that's how I got the chance to go to the library and work on problems that we couldn't solve by ourselves with other like-minded students. So, I suggest that whatever people say, you should always do the homework yourself first, and then attend the study group and work on the difficult problems and check with other students. And if that doesn't work and you still have confusion, then of course come to office hours. My next tip is to question the teacher and the TAs. Sometimes they'll make mistakes, like they'll write a carbon when they really mean hydrogen. And you'll think, shouldn't it be hydrogen? But oh wait, I'm not the OChem expert here, so I should just go with whatever the teacher said. After all, nobody else is saying anything, so I should just move on. But please don't be like that. If you suspect a mistake, ask for clarification. If you don't ask, you don't know. And maybe you're afraid of embarrassing yourself, because what if the teacher is right and you were wrong about suspecting a mistake? Well, chances are 100 students have the same exact question as you, and instead of making fun of you, they're actually thanking you that you were the one who spoke up and asked for clarification. In general, when you're confused about something, you should just ask for help. Otherwise, what happens is that you keep on learning new material when you still have holes in your understanding of older material, and eventually you have so many unanswered questions that it just becomes very discouraging to keep on learning. Never let that happen to you. Stay afloat, ask questions, get answers. So somehow the video for this segment got deleted and everyone's sleeping right now, so I'm gonna be really quiet. Basically, this tip is about doing it for the memes. It's kind of weird, but I'm dead serious. So basically, a lot of people, especially if you're like a pre-health student, you'll think that OChem isn't really a good use of your time. Like, it's not gonna be a part of your future career. Like, why would I have to do it? And you think it's useless to learn organic chemistry. But it's not a waste of time if you post memes in your group chat and maybe on Reddit. There's an interesting relationship between memes and learning. It kind of goes both ways. Memes make learning fun, and the more you learn, the more you're able to make memes. So it's kind of a cycle. It's not a vicious cycle, because who hates memes? They're one of the best things about life in general, really. I legitimately believe that memes are one of the major reasons I did well in organic chemistry. It's just this social aspect of sharing memes that makes learning quite charming, I believe, and you have the potential to make friends through bonding with light-hearted content about otherwise inconsequential topics. I hope my tips help you, and all in all, I think the big takeaway is this. You now know the answer to the question, is organic chemistry about chemical concepts or about memorizing reactions? And the correct answer is both. In OChem 1, it'll feel like there's more of a balance between the two, but in OChem 2, it'll certainly feel like you're memorizing reactions more because you're already used to the principles that you learned in the previous course. So, if you're in Dr. Page's class, which means you're not just some person randomly watching on YouTube, then my office hours are on Tuesday at 4 o'clock, and I and the other TAs are happy to help you with any questions you have over the course material. Hope to see you then. Stay safe and peace out.